Okay. Well, very good morning, guys. Fine. So last day we've just been discussing about inheritance, right? We started up our discussion about inheritance, and we've just been seeing how to perform inheritance. It's a simple process. What's it? You define a class with a set of members, and then you made that class as a parent class of the second one. So internal class, class 2, colon, class 1. Now you can create the instance of the class 2 and call the methods of class 1. What did I say? Child classes can consume the members of the parent class as if they are the owner of those members. Are you clear? You're straight away creating the child class instance and calling the parent class methods. So child classes can consume the parent class members as if it is the owner of those particular members. So straight away you can create the child instance and call the parent class members over there. Okay, so that's what we are doing now. So C refers to what? Child class. Guys, can I add new methods in the class 2? Can I add new methods in the class 2? Yeah, you can add new methods in the class 2. See, public void test3 console dot write line method 3. So added 2 more methods here now. So now coming here, I'm calling C dot test3 and C dot test4. So the first 2 are child class methods. If you observe, both will be accessible to you right now. What both? Parent methods, child methods, both. So actually, how many methods are available, are present in class 2, child class? How many methods are present in class 2? That is child class. Louder. Wrong answer. 4 here. You inherited 2 methods. Now, what is my question? How many methods are defined in the class? I asked. How many methods are present? I asked you. 4 methods are present. Why? 2 methods inherited from parent. 2 methods defined in the child. Totally, it is 4 methods. Tomorrow, someone asked me what is my property means. I not only say what I earned. I not only say what I earned. I also say what my parents has given to me. What my parents have given to me plus what I have earned is my property. Is it clearer or not? So whatever your parents has given to you and whatever you have earned is your property totally. So exactly the same thing I'm telling you here also. What? What? The methods, what are the members of the child class means? What is inherited from the parent plus what is defined in the child? Everything. So totally how many methods are there? 4. How many methods are there in parent class? Class 1? 2. Class 1 has 2 methods and class 2 has 4 methods, not 2 methods. You should say 4 methods. 2 are defined, 2 are inherited. Is it clear, all of you? Last day what I said to you, inheritance is a very simple and easy process. No need to talk more on this, but what I explained to you, when you're working with inheritance, guys, you're required to understand a set of rules. When you're working with inheritance, you're required to understand a set of rules. There are a set of rules what you're required to understand with inheritance. Okay, so I repeat, you have a set of rules what you just required to understand when you're working with inheritance, and there are 6 important rules here to learn. There are 6 important rules here to learn. So what are the 6 important rules that we are required to learn in the inheritance? Okay, let's try to understand about the 6 rules that we just required to learn in the inheritance. Carefully observe. Did I define a constructor in the class? Yes or no? No, we did not define a constructor. So we have an implicit constructor now. We have a implicit constructor. Now when you come to class 1, did I define a constructor here? No. No again. So do I have a implicit constructor? So to be clear, in both the two classes, we have an implicit constructor in action. Understood all of you? To be clear, in both the two classes, we have a implicit constructor in action. So we did not define the construct explicitly, and we are just using the implicit constructor here. We are using the implicit constructor here. Both of them are going to have an implicit constructor. We don't have an explicit constructor. Implicit constructor is available. Fine. Now, see, just now I'm executing class 2. No issues, executing perfectly. Now I came to class 1 and I defined a new constructor in the class 1. I defined a new constructor in class 1, public. I'm sorry. Yeah, I want to define a new constructor in class 1. Just a minute. Okay. So now if you just concentrate on this, one, I want to define a new constructor. Okay. So I'm defining a constructor, console dot write line. Which class is it? Class 1 now? Class 1 constructor is called. Nothing guys, I defined one constructor in the class, that's all. Okay. After defining this constructor, again I'm running the code. When I run the code again, I'm getting an error now. You understand, when I did not define a constructor, the code is executing. Which class? Actually, we are running class 2. Which class are we running? Class 2. See there. What we are running is class 2. When I did not define a constructor in class 1, see, listen, understand the confusion now. When I did not define a constructor in class 1, class 2 is executing perfectly. Yes or not? But when I am defining a constructor in class 1, I came now defined a constructor in class 1. When I defined a constructor in class 1 and come to execute class 2, I am getting an error. What could be the reason? Where I defined constructor class 1, but class 2 is not running. Did you catch my point or not? Where I defined the constructor class 1, but what is not running? Class 2 is not running. What is the problem here? Why is it not running? Let me clarify. Do you remember we discussed on this? What happens when you create the instance of a class? When we create the instance of the class, the 3 actions are performed. We discussed. First thing, reads the classes to identify the members. Reads the classes to identify the members. Okay. So on the day when I explained about this one to you, yeah. What happens internally when we create the instance of any class, internally following actions will take place. What are those? Invokes the constructors of all those classes, allocates the memory that is required. Okay, but just read the question. What happens when we create the instance of a class? Instance of a class. Singular or plural? Singular. It is single. One class. But what is it telling you? Reads the classes. Why classes came into picture? Did you understand my question? What is the question? What happens when you create the instance of a class, singular? But what is it telling you? Reads the classes. Are you clear? Sir, if it is the instance of a class, why are you telling reads the class? We should say reads the class to identify its members. Yes or not? But this was telling reads the classes. The reason why I said you reads the classes, because when you create the instance of a class, it not only reads itself, but it is going to read its parents also. It's not only going to read the members of itself here, it will also read the members of its parent also. Are you clearer or not? See, tomorrow, do you want to enjoy your ancestors' properties? Right? Do you want to enjoy your ancestors' property or give it to charity? Tell me. You want to enjoy the property now? So if you enjoy the property, first you should know what is present here. First you should know what is your ancestral property. See, there are some dynasties in the country, still they don't know what are their properties also. What are their properties also? In the Kerala Travancore dynasty, there are a lot of properties. In Hyderabad Nizams, the Hyderabad Nizam's property is countless. The Hyderabad Nizam's property is countless. How much properties they have, they don't know. So they don't know how much property, where they have lands, where they have property, they don't know still. So the thing is, if you want to enjoy, first we should know what is present. Did you get my point or not? What you require to know is what is present. You require to clearly understand and know what is present. So exactly the same thing I'm telling you here also. What is it? You want to consume the parent class members, then first know what is present in parent class. Without knowing what is present in parent class, how will you consume the parent class members now? Are you clear? That is the reason why, even though you created the instance of the class 2 here, all of you carefully, even though you created the instance of the class 2 here, first it will go to class 1, identifies the members of the class 1, then comes to itself, identifies the members. Tomorrow, you are defining a new class, class 3, inheriting from class 2. And you created the instance of the class 3. What will it do, It will start from class 1, identifies the properties. Next, 2, identifies the properties. Next, class 3. You have 10 classes in the hierarchy, 10 classes, 1 to 10. You create a 10th class instance now, where it starts reading from class 1 to class 2. Why? Not only my father here, my grandfather property also I am a owner. Yes or not? My father, my grandfather, my grandfather, all the property is I'm the owner now. So luckily, if it is a single child, it is a single child. Your grandfather has only one, and your father has only one. Then you are the owner now. Yes or not? If multiple children are present also, still you are a owner, but complete property may not come to you, but still you are a owner of all those assets. Yes or not? So that's the point all of us has to understand. So it will read all the classes, starting from the first class to the last class. It starts reading each and everything and identifies each and every member in this process. Is it clearer or not? Identifies each and every member in this process now. I shown you this picture in the last class to you. Parent and child relationship. Yeah, this picture I shown you in the last class, parent-child. Now watch this picture. This is creating the instance of the child class C. First it gathered the information of class 1. If you create class 3 instance, then you will have class 1 information, class 2 information, class 3. Your 10 classes in the hierarchy create a 10th class instance. Information from 1 to 10. All the 10 class information will be available there. Is it clear, all of you? So did you understand now? Why did I say reads the classes now? Are you clear? Second, what is the second thing? How many classes it read, it will invoke the constructors of all those classes. How many classes it read now, it will invoke the constructors of all those classes. Today, how many classes it read? 2. So it will invoke the two class constructors. Tomorrow you create 10 class, you have 10 classes now. You create a 10th class instance. It will invoke all the 10 class constructors. Who will invoke? Not me. My object will do. When I create the object, this will happen. When I create the, how it happens, when you create an object, first control goes to current class constructor. Listen, when you create an object, first control goes to current class constructor. The current class constructor will go now and call the parent class constructor. The current class constructor will go and call the parent class constructor, its parent class constructor. That class will go and call its parent class constructor. That will go and call its parent class constructor. Like this, if you have 10 classes in the hierarchy and created the 10th class instance now, what happens, 10th class constructor will go and call 9th class constructor. 9th class constructor will go and call 8th class constructor. 8, 7, 6, 5, 4, 3, 2, 1. Are you clear? And from there the execution starts. From there the execution starts. Which class constructor executes first? First class, second class, third class, fourth class. Like this, all the 10 constructors will be called. Now you'll be wondering, sir, why to call parent class constructor? Why to call a parent class constructor? What is the need of calling parent class constructor? Do you want to consume the members of the parent class? Come on, yeah. You want to consume now? Without initializing, how will you consume? Use your common sense there. Without initializing, can you consume? Who will initialize? Constructor will initialize. All are linked here. We learned already. Who will initialize? Constructor. So without a constructor call, are the members initialized? Not initialized. Then how can I consume? Point clear? So that's way the current class is going to its parent and calling its constructor. And what is that doing? That want to consume its parent member. So that will go and call its parent. That will go and call its parent. Like this, ultimately what is in the top, that class constructor starts the execution, and from there all are called to you. You want to construct, see, basically you have a land, guys. You have a land. Some 300 yards of land is present. And you have 3 in your family. Brothers or sisters, but you have 3 in your family, and that land belongs to all the 3 now. That land belongs to all the 3. Because today, daughters are also given the equal right on the property. So, if you have ladies, you have boys or girls, whatever it is, all the 3 have equal right on that. Okay now? And what happened now? You can divide them into 100, 100, 100 yards. What happens if you divide it like this? You will not get a proper house. You will not be getting a proper house. So what you guys planned is, what you people planned is, all the property belongs to us only. Huh? So let us do one thing. Let us just build, in the 300s only, let us build a separate floor for each, so that we'll get a big house. See, dividing into 100 and building a house now, it will be like a railway compartment now. Yes or not? It will be like a railway compartment. Okay? Room 1, room 2, kitchen, dining, like this, you'll have a railway compartment only. You will not get a spacious house. So what you people thought is, let us just construct a good house, a lavish house. Let us build one floor each. Total land is yours. So each one will build you one floor now. This is what you planned. Okay, now you are the younger. If you are the younger one in the family, see, basically we have a lot of principles and traditions what we follow, like Vastu and all. So when you go that, you are the younger, you should always be in the top floor. You are the younger, you'll always be in the top floor. Yours will be the third floor. Okay? Now tell me, if at all you want to construct your house, you have a dependency now. Yes or not? The first one has to build a house in the ground floor. Second one has to build on that, and afterwards you build. Can you build your house directly? Can you build your house directly? Why? There is a dependency. There is a dependency. What is that? The third floor depends on the second floor. The second floor depends on the first floor. There is a dependency now. So the dependency cannot be avoided. Are you clear? So same way, class 2 has a dependency on class 1. So until and unless class 1 is initialized, class 2 cannot execute. I hope the point is clear, all of you. That is the reason why it is going and calling. So did you understand? Invokes the constructors of all those class. How many classes you read? All those class constructors should be invoked. How many classes did you read now? 2. So 2 constructors should be called. Okay. First, which class constructor is it goes? Instance creation jumps to current class constructor, means class 2. Now class 2 constructor will call which constructor? Did you understand the process? Sir, what is the link between that and now defining a constructor now? That your question will be, sir, when I did not define the constructor, this code was executing fine. This code was executing. When you define this constructor, now getting the error. This is the problem, but you explained something else to us. I was explaining that only, guys. What is it? When you did not define a constructor, do you have a constructor in the class? Yes or not? What constructor? Implicit constructor. And do you guys remember this point? Implicit constructors are public. You're not reading here. Once after going home, you're not reading. I already shown you all these things to you now. We already talked about it. Implicit constructors are public. When implicit constructors are public, now you can call it, correct? Yes or not? But when I define the constructor, I got the problem, right? Yes or not? Did I give any scope to it? Did I give any scope to it? What is the default scope for the members of a class? Private. So the constructor is public or private? Private. Last class I explained you one point, remember? Child classes can consume the parent class members as if they are the owner of the members except private members. Right now, the problem when I define the constructor is I did not make it public. I left it private. So what is the problem? Class 2 cannot call the class 1's constructor. If you go and see the error message, where is the error coming? In which file the error is coming? Error is not in class 1. Error is in class 2. Class 2 is the error. What is the error? See? Clearly telling you here, class 1 dot. First one is your class name here. Second one is your constructor. Is inaccessible due to protection level. Because of the protection level, that is inaccessible to you. Because of the protection level, that is inaccessible. It's not accessible to you in this case now. So class 2 is inaccessible to you in this case now. So that is why you are facing the problem. So did you understand? So the first rule of inheritance is parent class constructor must be accessible to child class. That is the first rule. Are you guys clearer or not? What is the first rule? Parent class constructor must be accessible to the, if not accessible, inheritance is not possible. Why it should be accessible? Because child class constructor implicitly calls the parent class constructor. Why will it call? Because if the parent class constructor is called, then only parent class members are initialized and can be consumed under the child. Are you guys clearer? All are interlinked now. What is that interlinked? Child class constructor will go and call parent constructor. Why? Because child class wants to call the parent class members. Child class wants to consume the parent class members. If at all it wants to consume the parent class member, they must be initialized. So go and call the constructor, initialize, then consume. Point clear all of you? Any doubts? Tell me. So shall I prove you? First parent class constructor will execute? Okay, very simple. I'll make it public. Sir, when you did not define the constructor, this problem did not come. Common object create for all classes. What is it? Common object creating for all classes. You're changing object-oriented programming now. You cannot create any common objects. Okay, so see, I'll make it public. If I make public, see now all of you. Look at the code. What is called? What is called? It is going to call you the parent class constructor now. It is going to call the parent class constructor. Okay. See right now, when it did not define the constructor also, that happens here. That is implicit constructor, no code there. That is why we are not seeing any output. That is why we are not seeing any no code there. But now you are writing the code now. See now, you're writing the code now. Point clear, all of you. Now you're writing the code. You are writing the code now. See here, I'll show you one thing. Watch. Now let me come here. Here also will define the constructor explicitly. What constructor? Class 2. Class 2. Okay. Observe the output, all of you. What is called first? What is called next? You want a still clarity? Debug. Put a breakpoint here. Main method is here only, na? Class 2. Put a breakpoint here. What are you doing on this line? Creating which class? Tell that. Child class. Creating child class. Class 2 instance. Child class instance, right? Come on, start. Use F11, guys. Use F11. Where the control is jumping, watch. Current class constructor. That only is at you. Control jumps to. But this won't execute here. Watch, eh? Where it came? Suppose if class 1 has a parent class, now the control jumps to there now. Are you clear? If class 1 has a parent class, the control jumps to you there now. Are you clear? So right now we don't have a parent class for class 1. So that's why it is executing this code. Coming back, see there. Came back here. Now tell me from where you came here. From where you came here originally? From main. From main. You came from main originally here. You came from main. Now see. Back in the main. See, listen. Class 2 main method. 2. Class 2 constructor. 2. Class 1 constructor. Back to class 2 constructor. Back to class 2 main method. Are you guys clear or not? Understood, all of you? So is it proven? You do one thing. What you do? You add class 3. Inherit from class 2. Write a constructor there. Create an instance. Put a breakpoint and watch. I'm leaving it for you. Put a breakpoint and watch. First, control jumps to class 3 main method to which constructor? Tell that. Class 3 constructor. From there to class 2 constructor. From there to class 1 constructor. Executes that code. Comes back to. Executes the code. Comes back to. Executes the code. Comes back to class 3 main method. If you want to add 4th class, 5th class, 6th class, add, debug and watch. Are you guys clear? Understood, everyone? So what is the first rule of inheritance? What is the first rule of inheritance? Forgot already. Parent class constructor should be accessible to child class. 5 minutes only you don't remember, and you will go to interviews now, get the company jobs in the companies and change the fate of the companies now. 5 minutes back I said you forgot already. What is that? Parent class constructor should be accessible to child class. If not accessible, inheritance is not possible. Okay, now? So next, the next question will be why it should be accessible. Why it should be accessible? Because child class constructor is calling the parent class constructor implicitly. Child class constructor will call the parent class constructor is implicit. Why is it calling? Because if it is called only, parent class members will be initialized and then can be consumed in the child class. All these are interlinked process. All these are going to be interlinked process. Yes or not? You can have a big machine. You can have a big machine. The machine has so many functionalities in it. All are interlinked. Yes or not? But suppose if you see, if any small part like a fuse or anything gets spoiled, the complete machine will not work. Am I right? Everything is interconnected. Everything should work perfectly. Then only the machine runs. So here also the same thing only we just have in this case now. Okay. What is default of accessibility? Private is default for class. Wrong. What is the default scope for a class, guys? Louder. Internal. The default scope for a class is internal. The default scope of all the types is internal. Don't forget again and again. Already pinpointed you, and every day you're getting it also. What is the default scope? What the default scope for members? Private. Type scope is internal. Member scope is private. If you don't specify anything. Writing internal here is mandatory or optional? Optional, because I don't write that also, that is internal only. If I don't write that also, that is internal only. I said the type na, again why you're telling interface, structure, type I said you na. When I said type, how many types are there? 5 types are there. Classes, structures, interfaces, enums, delegates, all will come. Why you pinpoint everything again? Type, all the 5 will come. Member, all the 8 will come. How many types are there? 5. Class, we are talking on that only. We still did not go beyond because class is only the important member for us. Second, interface. Third, structure. 4, enum. 5, delegate. We'll talk on the rest of the 4 also. We'll talk on the rest of the 4 also. Class, structure, interface, enum, delegate or types. What is the default scope? Private. Sorry, what is the default scope? Internal. The default scope is internal. Now members, 8. Members means 8. What are the 8? Fields, methods, constructors. We already completed these 3. Next, finalizer, property, indexer, events, deconstructors. These 8 are members. Default scope is private. Okay, na? So don't forget it again and again. Type means 5. Type means 5. What are those? Class. Second one, structure, perfect. Interface, enum, delegate. These 5 are types. Next, members. How many? 8. What are those? Fields, methods, constructors. Fourth one, finalizers. Fourth one is finalizer. Fifth one, properties. Fifth one is properties. Sixth one, indexer, not index, indexer. Okay. Next, 7, event. 8th, deconstructor. 8 members and 5 types. Types are always internal, members are always private. That is the scopes. Clear? Default is that. If you want to change, change to your requirement. So when I did not define a scope for my class 1 constructor is private. So class 2 was not able to call it. Class 2 was not able to call it. Are you clear? Okay. No, will not have, Manoj. We'll talk about that. Will not have. We'll talk about that. Okay. So fine. Fine. Are you clear with the first rule now? Yes or not? Second rule is very simple and easier. What is the second rule? You know, all of us know this. What? Child classes can access the parent class members, right? But a parent can never access the child class members. Child can access the parent members, but a parent can never access the child class members. Why, sir? A parent never know who is his children, guys. A parent never know who is his children. Parent never know the children. So many classes can inherit it. Every class it won't recognize. Every class it won't recognize. Are you clearer or not? Understood my point? All of you who are using Windows operating system, and all of you, so many people, you are using the Windows operating system, Visual Studio, and all of you know about Microsoft and Bill Gates. Does Bill Gates know each and every one of you? Because you are using Windows, does he know you? He doesn't know you. Are you clear? So here also same point. What is it? A child always know about its parent. A parent never knows about its child. So that's why parent can never consume the members of the child classes. Parents can never consume the members of the child classes. See, in the law also, is a law, you know that? Children have right on the parents' property, right? Yes or not? But parents never have right on the children's property. Parents never have right on the children's property. It is the responsibility of the children to take care of their parents. But legally, parents doesn't have any right on children's property. Are you clearer or not? Understood my point? Same rule only that we are talking here. What is it? Child classes can consume parent class members, but parent classes cannot consume child class members. Is the point clear? Okay. So if you want, you can observe. I am directly creating class 1 instance. I am directly creating which class instance? Class 1 instance. What is the name? P. See now, P dot test 1 valid. P dot test 2 valid. But P dot test 3 and P dot test 4 are invalid. Invalid calling because these are child class methods. Invalid calling because these are child class methods, all of you. Are you clear? So you can see error coming there. That's a clear proof to you. Guys, no need to run any program here. Everything IntelliSense will show you. P dot. See the list. 3 and 4 are not coming. That's enough to understand. You can't access. Okay. If you try to, you get error. So if I comment this only, code will execute now. So it can call test 1. It can call test 2. Now see, you created parent class instance only. Child class constructor did not get called here. What gets called? If class 1 has a parent, that constructor is called. Not class 2. Because class 2 is a child. Is the second rule clear? Tell me. That is simple, yaar. That is very simple rule. What is the simple rule? Yes, Srikanth. Nothing happens. Array, field and variable can have a same name. Within the class only we can have two with the same name. Why can't we have in parent and child? Within a class only a field and a variable can have same name na? So you have to ask the question. What are the questions, sir? Can I in a parent and child also can I have the same name? Yes, you can have. We'll talk on all those things. Hold on. Don't be worried. Okay. So just understood the first and second rules now? Now third rule, guys. What is the third rule? Look. Watch it, what I'm doing. Class 2 obj1 is equals to new class 2. What did you do? Creating instance of child class. Perfect. Okay. Class 2 obj2. What are you doing? Creating, declaring, not creating, declaring variable. Forgetting every time. Variable. What is that? Variable. Variable of class 2. First line, creating instance of class 2. Second line, declaring variable. It's not creating, it is declaring. Okay, now? And you remember this? We can do this. Valid, na? Same class instance, same class variable. Initialization possible, we already learned. This is valid. This is valid. What are you doing? You're initializing the variable of the same class with instance of the same class. Old story, guys. We learned it already in the last week. Instances, references. In the banking ATM system also I said you, what is the need of that reference? Okay, now? Now, look, guys. Concentrate on this. I'm creating a child class instance. I'm creating a child class instance. Then I'm declaring a parent class variable. I'm declaring a parent class variable. Okay. So the new point what I want to tell is this is also valid. What, sir? Parent class variables can be initialized by using child class instance. Parent class variables can be initialized by using child class instance. Okay. Listen. Earlier, we have discussed that variables of the same class can be initialized by instances of the, this is old story. Same class variable, same class instance. What is the new story now? variables of same as the above, variables of parent class can be initialized by child class instance, but not did you understand? If you answer today, I'll continue the class. Answer, yeah. Did you understand? What is it telling you? Parent class variables can be initialized by using, but the reverse is not possible. Vice versa is not possible. What is not possible? Child class variables cannot be initialized by parent class instance. That is not possible. Okay. Let's first focus on the first thing. What is it? Parent class variables can be initialized by child class instance. Okay. Watch it all of you. I have just said class 1 P is equals to C and run the code. I don't have any compile time error or I don't have any runtime error. Yes or not? Means that is valid now. That is valid. Okay now? Now guys understand in this scenario, P and C both are accessing the same memory. Watch the picture. What is P? Reference. What is C? Instance. And both are accessing same memory, not class. Same memory. And this is the first class. First you saw na memory located now. Linked. Okay. Now, if you come here, the same memory is being accessible to P also. Is it clear? Now tell me. Using P, now can I call class 2 members? Come on, because previous example I shown you parent cannot call child members. In the rule number 2, what did I say? Parent cannot call child members. Now can the parent call child members? Let's verify, okay? Let's verify. First, test 1, test 2. Test 1, test 2 can be called. No discussions on test 1, test 2. No need to have any questions on test 1, test 2. Run. No confusions with the test 1, test 2. Yeah, test 1, test 2 can be called. Okay, na? The question is all about 3 and 4. The question is all about 3 and 4. Okay. So can I call 3 and 4 also? Let's see. Error guys. Not getting called. Not getting called. But both are accessing the same memory only now. Both are accessing the same memory. But rule is rule. What rule? Parent cannot access child members. What is the rule? Parent cannot access child members. Watch the picture. That only I extended, that's all. See, using C, I can call class 2 members, I can call class 1 members also. But using P, I can only call, but I cannot call, class 2 members cannot be called. Is the point clear, all of you? Yes or not? So that's what, you cannot call the class 2 members by using P. Using P, what can I call is only class 1 members. Simple here. You can look straight, you can look top, but you cannot look bottom. Stand on the road, look straight. And can you tell what is present before you? Tell me. Look into the sky, and you can see the clouds, stars, moon, sun, everything. Look into the bottom and tell me what is present inside the earth. Tell me. You can't say that, na? Same point I'm telling you. You can look straight, you can look top, but you cannot look in the bottom. Child members are not accessible. Child members are not accessible. Now you'll be wondering, so then what is the point of creating that? What is the point of creating that? See, everything will have a use. I'll tell you when the situation comes. When I explained you references in the last week, we did not understand what is the use of the reference until I explained you about the ATM system case study. Yes or not? We learned like references can be created, but what is the need of the reference? Don't know. But last day when we learned about the ATM case study, there we understood now references will come and sit on the client system and will help you in calling the members on the server, correct? So same way, this also has a usage. When the time comes, I'll tell you. Don't think beyond. That's what I'm telling. Okay? What I say, stick to the basics. For everything, I will show you practical implementations going forward. Going forward, you'll see the practical implementation for each and everything, guys. Any doubts? Understood my point? Okay. So what is that? You can look straight as well as you can look top, but you cannot look in the bottom. So this cannot call the child class members. Rule is rule. What rule? Parent cannot access child class members. Parent cannot access the child class members. Okay. So see, if a parent class reference is created by using child class instance, then parent reference starts consuming the memory of child class instance. But now also using the parent reference, we cannot call any members of child class. Are you clear, all of you? Why you cannot call? Rule is rule. What is that? Parents cannot access child members. The rule is rule. Parents cannot access child members. Any confusion? See guys, whether than you understand the descriptions or not, these pictures should give you the clear evidence for everything. Are you clear? If you watch the pictures, you should understand. First picture, class 2 instance is created. Both the members are read. Now reference created. The reference is consuming the same memory. Now reference cannot call child class members. Reference cannot call the child class members. Okay. So this creation is valid. This creation is valid. And now this call is valid. This call is invalid. This call is invalid. Okay now? Fine. Now tell me, can I do this? What? Class 1P is equals to new class. What are you doing? Creating parent class instance. What are you doing? Creating parent class instance. Class 2C is equals to P. Come on fast. Valida, invalida. What are you thinking? Invalid. Why? Array, read the first point here. Already mentioned you. Read it. Now read. Variables of parent class can be initialized by child class instance, but not the reverse. Reverse is not possible. What are you doing? Reverse. What is it? Child instance you're trying to initialize with the parent. Why is it not possible? Because, listen here, child knows about 4 members, parent knows only about 2 members. How can you do that now? Are you clear? Child knows about 4 members, parent knows about 2 members. So cannot do now. Okay. So the reverse is not possible. If you want, you can try. Is equals to new class 1. Are you clear? So class 2C is equals to P. When you run this, you get an error. And if you read the error message, what the error message is doing, what the error message is telling, read it all of you. Cannot implicitly convert type. Which one? Class 1 to class 2. An explicit conversion exists, or you missing a cast. What is it telling? Tell me. There are 2 points here, guys. Can you elaborate and tell me the meaning of both the 2 points? What is the meaning of the first point? I did not ask you to read it. I asked you to tell me the meaning of it. Describe it, guys. You cannot initialize a class 2 variables by using class 1 instance. That's what the meaning of it. You cannot initialize the class 2 variables by using the class 1 instance. That's the meaning. Second point. Tell me what is the second point telling you. Second point, where is it telling about class 1 or class 2? Understand English here. What is it telling you? First point is telling you what? Do you know what is the meaning of implicit and explicit? What is implicit? Internal, automatic, internally happening. Explicit? Manual. Explicit means manual. What is telling? Automatic conversion from class 1 to class 2 is not possible. So automatic or internal conversion of class 1 to class 2 is not possible. What is the second point that they're telling you? Manual conversion? Possible, huh? Yes or no? That's why I say you don't understand English. Huh? Question mark is there now, and question mark is there, you're telling yes, no. It is not telling, it is asking you. Follow grammar. It don't know. Compiler don't know. Why compiler don't know? Classes are defined by you. Why will compiler know? Classes are your classes or predefined classes? Huh? Classes are defined by you or classes are predefined? Classes are defined by you or classes are predefined? Classes are defined by you here. You written the class and you are telling nonsense. Predefined. Where you got predefined? You written class 1 now, you written class 2 now, and you're telling predefined, sir. Classes are user defined. You defined the 2 classes on your own now. Yes or not? Class 1 and class 2 are defined by you now. Correct? Then if you define, how will compiler know that? Compiler is asking you. What is it asking? You have a question mark in the end. See, what is it asking you? I know one thing. What I know? Implicit conversion is not possible. What about explicit conversion? I don't know. You check. Are you clear? That's what. Concentrate on the error messages. Error messages are very, very descriptive. They tell you everything clearly to you. What is the first point telling you? Implicit conversion is not possible. I'm sure. Okay. Implicit conversion means who has to? Compiler should do. So compiler is telling, I can do, because these are your classes. Okay. Then what about explicit conversion? Explicit conversion possible or not possible, you only should tell. I can't tell that. These are your classes and you only should tell that. What is explicit conversion, sir? What is explicit conversion? All of you concentrate on this. We already learned about explicit conversion number of times. What is that? Int x is equals to 100. Okay. Object obj is equals to x. Implicit conversion. What is it, guys? Boxing, implicit conversion, that is. Because these are predefined types. Int is not defined by you or object is not defined by you. These are all predefined. Implicit conversion, possible. Second option, see, int y is equals to convert dot 2 int 32 of obj. What is that? Unboxing. What are you doing? And remember, when you're done unboxing, you performed a explicit conversion. You performed a explicit conversion here. So did you understand what is implicit and explicit now? Implicit means direct assignment. Explicit means you're trying to do some conversion. You're trying to perform a conversion. Is it clear or not? See, suppose you have int I or float f. Float f is equals to 10.00 f. Can I convert this into integer? Why no here? After decimal you have zeros only. Na? If you can remove that, that is integer only. Na? Why you can't convert? See, when I cannot convert, now I cannot convert. Why I cannot convert now? You have values after the decimal, so conversion not possible. What you have now? 0 after decimal have meaning, huh? Then why you telling no? Mathematics here. You can do this conversion. How do you convert? Int I is equals to, you remember this? You learned in C language? Typecasting. That is also explicit conversion only. That is also explicit conversion only. Typecasting. That's called as typecasting. We learned about this typecasting in C language, converting from one type to another type. And remember here in C# only there are different conversion operations available. I one day explained to you in detail. You cannot use parse here. Parse can be used only on strings. What's the folder? E drive now. C# 9. Operators demo.cs. When I explained about operators demo, remember I said you conversions can be done in a variety of ways. Conversions can be done in a variety of options. I already elaborated and explained to you. Calling convert.toString I can convert. Second one, typecasting. See there. That is typecasting. Third one, as operator. That also is said you. As operator can be used for conversion. Fourth one, toString. All these four will be conversions. You can do variety of ways. Conversions can be done in variety of ways. What is an explicit conversion, you know? Means if at all you try any of this like this, these are called as explicit. Direct assignment is implicit conversion. But there we did not do direct assignment. See, did we do direct assignment? No. They are not direct assignments here. First line watch, that is direct assignment. What is it? Array string directly assigned to object. Implicit conversion. But object to string implicit is not happening. All are explicit conversions. You're required to do a explicit conversion. Now coming back here, all of you carefully listen what I'm trying to tell you. What I'm trying to tell you here is, see guys, it is telling you, I'm very sure implicit conversion is not possible, and telling you, you verify yourself if there is any explicit conversion. Let's try whether it is possible by explicit conversion. How? I'm doing a typecasting, guys. Class 2 of P. I'm doing a typecasting now. I'm converting P into which type? Class 2 type. I'm converting P into class 2 type. Run. Error. Error. So what is the meaning? Explicit conversion also not possible. Implicitly or explicitly. What is not possible? Child instances cannot be used for initializing parents variables. I'm sorry. Parent instances cannot be used for initializing child's variable. A little bit confusing here. The third rule of inheritance is a little bit confusing. So again and again, I'm pinpointing that's the reason why. What is possible? Parent variables can be initialized by child instances, but child instances cannot be initialized by parent variable. Implicitly not possible, explicitly not possible. Are you clearer or not? Okay, this is explicit, guys. You can write like this also. You can write like this also. P as. Simple English here. Convert P as class 2. What is the meaning? Convert P as class 2. That is the meaning. Now also error only. Now also that's error only. You cannot do the conversion of the P. See? It needs to give you a warning telling you it's not going to be possible. You cannot convert P as class 2. Implicitly not possible. Explicitly also not possible. These conversions will not work. These conversions will not work at all. Okay. See now, under third rule only, I demonstrated 2 points to you. Under third rule only, I demonstrated 2 points to you. What are the 2 points? Point 1. What is point 1? Parent variables. Parent variables can be initialized by child instances. Second point. Child variables cannot be initialized by parent instances. So this is invalid. You clear? Yes or not? Now I'm adding you one more point also here. What you know? See. Listen. This is the confusing thing now. Listen. We can initialize child variables. We can initialize child variables by using parent references that are initialized by. Can you understand the meaning of it? Read it thoroughly. Come on. Did you understand? Answer the question. Did you understand? What is it telling you? Child class variables can be initialized by using parent references, not instances, parent references that are initialized by child instance. What is that? Look at this. What is P? Parent reference. Initialized by child instance. Initialized by child. So using P, I can initialize a child variable now. I can initialize a child variable. Okay. Initialized by child instances by performing explicit conversion. This is why I am talking about implicit, explicit and all these things to you. How? By performing what? Explicit conversion. Watch, this can be done. What can be done? Class 2 obj is equals to P as class 2. P as class 2. Now you'll be wondering, what is that? Sir, with this P you said I cannot create class 2 variable. I cannot create a class 2 reference with P. You're telling again, you're doing it here. Array, that only I'm telling you guys. What is this? P is initialized by C. Don't forget. Is P directly initialized or P initialized by C? What is the difference here? P is a direct initialization, but here P is initialized by C. So using this P, I can initialize OBJ. But implicit or explicit is an explicit conversion. This is a explicit conversion. This is an explicit conversion. You can write like this also. Class 2 OBJ is equals to class 2 R of P. This is also, both are same, only are two ways to write the code. Both are same, just two ways to write the code. That's all. Both are valid. I'll tell you in a simple words, you will not forget again. I'll tell you. Remember boxing? What is boxing? Value type to reference type conversion is boxing. Okay? Now tell me, reference type to value type. Reference type to value type. What is this? Invalid, not unboxing. This is invalid. We can't do that. Correct? Now see, I have a value type converted into reference type. With this, can I convert back into value type? What is this? Unboxing. This is unboxing. This is valid. Are you clear? Okay, now? Now same like this only. Same, exactly same like this. I will tell you another 3 points. See, I have a child instance. I have a, using this, can I create a parent reference? Yes or not? Yeah, we already saw child reference, parent, where parent reference can be created. Child instance, parent reference can be created. Now reverse. What is that? I have a parent instance. Using this, can I create a child reference? Valid or invalid? Invalid. What is possible? I have a child instance. I have a child instance. With this, I created a parent reference. With this, I can recreate a child reference. This is valid. Are you clear what I explained here? Again, you can see what is the first point? Child instances. Not only I said, you see, child to parent conversion is possible. Child to parent conversion is possible. Second point. Not possible. Parent to child conversion is not possible. Third point. Parents references that are initialized by child instances by performing explicit conversion. See now, first child converted to parent, and from there you got back to child. So now you'll have a doubt. Sir, why I can't do this? Why I cannot do this? I very clearly said you this point here. When you create a parent instance, it will have information of only two methods. Test 1, test 2. Correct or not? With this, how will you initialize class 2? Class 2 has 4 na? Point clear? But then how is the last one possible? How the last one possible is, first what are you creating? So it recognized all the 4. With this you are creating and giving information only 2. But don't forget that reference have 4 objects information there. That memory has all the 4 objects information. But for P you are giving only 2. When I come to the child again, problem will not come. Why problem will not come? Watch. You are clear with this now? Yes or not? But don't forget here, this object contains information of class 1 and class 2 also. Now using P, when I initialize OBJ, OBJ is the reference what is newly created, pointing now accessing all the 4 members also. Understood? Concentrate on the memory allocation. If I create class 1 instance, memory is allocated only for 2 members. 3, 4 information is not there now. So initializing child is not possible now. But you already initialized the child with all the 4 members, Yes or not? For that, I'm giving access for 2 to you. But again, with this P only, when initialize OBJ, you will get access to all the 4 again. You will get access to all the 4 again. Is the point clear or not? Understood, all of you? You'll get access to all the 4 members. So that is why this is going to be possible. Okay. This third rule, third point, the third rule, third point, what I said here is a very, very important point here. And this will follow you until end of your classes, not C#, until end of your .NET course. This is not the first time we are learning. We will use it at least 20 to 30 times until the end of our course. Are you clearer? Yes or not? I'm pinpointing the third one only again and again for that particular reason only, because this is a very important rule of inheritance. Okay. So once again, you can come back and look. In the third rule, 3 points we discussed. First point, look here. First point, using a child instance, I can create a parent reference. Second point, using a parent reference, I cannot create a child reference. Using a parent instance, I cannot create a child reference. Third point, using a parent reference that is created using a child instance can be used for creating a child reference. Can be used for creating a child reference. This is going to be possible. Okay. So let us sum up all the things what we discussed today. Rule 1. Rule number 1. This is point number 1. I asked you rule number 1. Alright, this is point number 1 in rule number 3. I'm asking what is rule number 1? Parent class constructor must be accessible to child class. If not accessible, inheritance is not possible. I have proven you practically. Put the breakpoints, run the code, watch your output. You'll understand, you'll get a clarity. Why is it not accessible? Why is it not going to be executed without accessibility? Rule number 2. What is rule number 2? Child class can access parent class members, but parent class cannot access child class members. A parent can never access the child class members. Rule number 3. Under that again we learned 3 points. Under rule number 3 only 3 points we learned. What are the 3 points? Parent variables can be initialized by child instances to make them as references. Parent variables can be initialized by child instances to make them as references. That's what I said you. Child instance to parent reference possible. Second point. Parent instances cannot be used for initializing child class variables. Parent references cannot be used for initializing the child class variables. Rule number 2 clear? Rule number 3. Parent references, not parent instances. Connect me correctly. Not a parent instance. Parent references that are created by child class instances can be used for initializing child class reference. Can be used for initializing the child class reference. All of you here, what is the new one you created? OBJ. And all of you watch this picture, OBJ. Using OBJ, can I call class 1 members? Yes. Class 2 members? Yes. Look at the location. Where is it pointing? You can look top. You can look top, but you cannot look in the bottom. That's what I said you. You cannot look in the bottom. That's why P can look to class 1, but P cannot look to class 2. Previous picture. Okay, now? Read them carefully, all the 3 rules thoroughly. All the 3 rules thoroughly. Put breakpoints in your code and start debugging and just try them. Clear? We have another 3 rules we will talk tomorrow. Let's stop it here.